This is number 38C in chapter 18. It's asking us to balance the following redox reaction that occurs in acidic solution. Part C involves manganate plus aluminum, which is in a redox equilibrium with manganese plus 2 and aluminum plus 3. And so we need to balance this process. This is in acidic solution. So the first part is we have to recognize the changes in oxidation numbers. If we look at our oxidation numbers, we have a total of -8 from our oxygens. That means our manganese must be +7 in order for the sum of those oxidation numbers to equal the overall charge, which is -1. For aluminum, that's elemental, so that would be 0. And for these charged metals, they are simply the charge on the metal as +3 and +2. So that means the manganese is going from +7 to +2, so it is being reduced, and so that means our other species, the aluminum, which is going from 0 to a +3, has to be being oxidized. The manganese would be accepting electrons that go from +7 to +2. The aluminum would be losing electrons that go from 0 to +3. And so if we begin with the manganate, let's begin a little bit more in the middle here. First thing we do is we balance the atoms. Manganese is balanced, oxygen is not. We are going to balance out our oxygens by adding water to the opposite side. Now that we have added water, we have to balance out our protons on the other side. So we have 8 protons to balance out our hydrogens, and now all of our atoms are balanced out. We need to balance out our charge. We have a total charge here of +7. We have a total charge here of +2. And so that means we have to add 5 electrons to the starting material side. The manganese is being reduced, so we should expect those electrons to be there. Since for the reduction, the manganese is accepting those electrons. We balance it out with charge. Let's make sure that that is verified via just the redox numbers or the oxidation numbers. And if we look up here, we're going from +7 to +2, so we should expect 5 electrons. And so that is what we get. So that is the reduction half reaction, and it's balanced. Now let's go to the other process, where we go from aluminum as solid to aluminum +3. And so this is a much easier one to balance. The aluminums are balanced, so all the atoms are balanced. There's no oxygen, there's no hydrogen, so we don't have to worry about protons or H2O. We're really just looking at electrons. And so to balance out our charge, we have 0 on the left, we have +3 on the right, so we have to add those 3 electrons. So now these two are balanced, but we want to multiply through both of these now before we add them together to get the whole redox equilibria, to make sure that their electrons are actually equal. So we're going to multiply the bottom by 5 and the top by 3 to make sure our electrons are balanced out. And so when we add up these guys, we would have 15 electrons plus our 24 protons plus 3 manganetes plus 5 aluminums goes to produce 3 manganese plus 2 plus 12 H2Os plus 5 aluminums that are plus 3 plus, sorry for running out of room, 15 electrons. And so now that we have the sum of these guys, we want to cancel out species that appear on both sides of the equilibria. The first thing that we should cancel out should be our electrons, and they should be equal because that's really what we did here in the cross multiplication step. And now that is it. Everything has been reduced out. And so if we then just rewrite this to represent everybody, we have 24 protons plus 3 manganetes plus 5 aluminums is in equilibrium with 3 manganese plus 2 plus 12 H2Os plus 5 aluminums plus 3. So I just restated the whole process. If we look at the redox equilibrium now, we can't reduce it any further, so this should be balanced. And one way to check is to again look at the charge on the left and on the right. And so on the left we see 24 protons and 3 manganetes, so that would be a total of plus 21 for the starting material side. For the product side, we have 5 aluminums that are plus 3, so that's plus 15. And then we have plus 6, that means we have plus 21 on the right. We are balanced with charge as well. And so that is the answer for number 38C.